In this video, we are going to solve some problems on linear momentum based on force time graphs. Graph below shows the force acting on a 400-gram cart. What will be the approximate change in momentum? So we know that the area under force time graph gives us change in momentum. So let's just write that down. Area under FT graph gives us change in momentum. Now here the shape of the graph is not a triangle or a rectangle to apply the formula for area for regular shapes. It's a curved graph. So we want to find what's the area under this graph. So in this case we are going to count the grids. So first let's just count all the full grids. So what I mean by grids is this square, this small square which you see, that's a grid. So you can see that how many full square grids are there. So 1, 2, 3 and 4. There are full grids, 4 full grids. So let's just shade them. So we have got 1, 2, 3, 4 full grids. Now we'll count the grids which we can consider as one grid if we combine them. So for example, if we take this grid and this grid, that can be taken as one. Approximately it is one grid. So we got how many grids here? 1, 2, 3, 4, and these two together makes it 5. Because this is half a grid and this is half a grid. Then we have got a grid here, it's almost complete. And then this grid and this grid. So we can consider these two as one grid. So let's take, so because it's approximation, so don't worry about be very exact on it. So these two blue dots which I have drawn, that's your one full grid. So let's just number the grids. So this is 1, this is 2, this is 4, 3, this is 4. So 4 full grids, and then these two make the 5th grid, these two make the 6th grid. So we have got 6 full grids. I can take this one as also almost complete grid. So only a little part of it is missing. So I'm going to take it as the 7th grid. And then this grid which is left out, that is half a grid. So that will be 0.5. So let's just shade it first. So let's say this grid is 0.5. So let's just write that. That's 0.5. That is half a grid. So we have got once again 1, 2, 3, 4 full grids. Then these two make 5th grid. These two are 6th. This is almost one full grid, so 7. And then you have got half a grid. So we have got total area is 7.5 grids. Now we want to find what's the area of one grid. So one grid, if you look at the graph, this is one grid. So one grid is having a side or height of 2. How do I get 2? 6 minus 4 is 2. And the width of 1. How do I know that? Because 6 minus 5 is 1. So anywhere if you see, anywhere if you check the height and the width of the grid or length or breadth of the grid, it is 2 by 1. That means the area of one grid is equal to 2 times 1, which is equal to 2. Now we have got 7.5 grids, so area of 7.5 grids will be 7.5 multiplied by 2, which is equal to 15. And we know that this area is equal to the change in momentum which we want to find. So the approximate change in momentum will be equal to 15. We have to put the unit. You can put Newton second, or you can write it as 15 kg meter per second. Both are correct. So remember, when you have such a problem in which the graph is not a proper shape, then you have to count the number of grids under the graph like we did in this problem. Then find the area of one grid using the
calibrations or the numbers which they have given on x and y axis. After you find the area of one grid, then find the area under the graph to find what's the change in momentum.
Okay, this is another type of problem on linear momentum. Not another type, but the graph is different. It's a regular shape. We can identify the shape of the graph. It's not a curved graph. The question is asking us to find what's the change in momentum from 1 to 2 seconds. So we can see that it's again an FT graph. So area under FT graph gives us change in momentum, as we said before. Now it's particularly asking for 1 to 2 seconds, so we need to find out where is 1 to 2 seconds on the graph. Let's shade that area. So we will focus on this area. We want to find the area of this shape. Now this is a trapezium. It's not a rectangle or a triangle. So we will divide this into a rectangle and a triangle so that we can apply the formula for area. So we can see that this is a triangle and this shape is rectangle. Now the side here is 2 minus 1, which is 1. The height here is 2. So for the rectangle, area for the rectangle, I can write length times breadth, which is 1 times 2, which is equal to 2. And area for the triangle, the formula for area for triangle is half times b times h. The base of the triangle is again 1. How do I know that? This is 2, this is 1, so 2 minus 1 is 1. And the height here, we can see that it's 3 minus 2, which is also 1. So we can write half times 1 times 1, which will be 0.5. So delta P, which is the total area, 2 plus 0.5, which will be 2.5, and the unit will be kg meter per second. Or there is one more unit for delta P, which is Newton second. Both of them are correct. So you can write delta P as 2.5 Newton second also.